Hello everyone, welcome to my channel Strong Math. Today in this video we'll discuss about the basic concept of real functions. Watch the video very carefully till the end, don't skip the video. This is the first day of our video lectures related to functions. At first, what is function? Simply, a function is a rule. In particular, a rule relies on an input and generates an output. You can think of a function as a machine. Basically, at first, we will try to understand what is a function. Very simple examples. If we choose a machine, okay, say this is a machine. Suppose that machine is named as F, and I say that this is a rule also. By this rule, if we put some inputs here, after taking the inputs, this machine goes on to work and produce some outputs or results. Okay, here simply think for a function f of x equals to x plus 2. We are giving some inputs, that is x, and then we get the results as x plus 2. For example, if we input 2, 3, etc., then the function or this machine goes to work according to this rule, that is if we put some x, then the result gives us x plus 2. So if we put 2, then it gives us 2 plus 2 as a result, which is equals to 4. If we put 3, then it will gives us 3 plus 2 equals to 5. So we input some objects as number into the machine. The machine goes to work on the input objects. The machine generates an output like numbers. This is the basic concept of a function. Let us define a function. A relation f from a non-empty set A to another non-empty set B is said to be a function or mapping. Function is known as mapping also. If every element of the set A has one and only one image, which is our output in the set B. I have already given the knowledge of relation in the previous video. I hope you have understood that lecture. So a relation f is said to be a function from a non-empty set A to another non-empty set B if every element of the set A, that is the first set, has one and only one image in the set B. That is, look here, if we put 2, then the function or the machine gives us the result or output as 4. For 3 we get 5. Here for each element we get one and only one output. That is, suppose this is set A, this is set B. If we take any inputs from the set A, we get its only one image. Okay, maybe in sometimes for this input we get the same image also. This is called a function. But suppose there are 3 inputs and we have some outputs there. This input can't map with 2 outputs. Okay, this is not a function. So this is the basic concept of function. 2 inputs can map with the same output, but one input cannot map with 2 different outputs. Clear? Let us see the standard definition of function. Let A and B two non-empty sets. A relation f from A into B is called a function or mapping from A to B if number 1, domain of f equals to A. I hope you can understand what is domain of a relation. I simply define the function as taking function f as a relation also, so you can understand What is domain of a relation? Domain of f equals to a for all order pair element xy and x prime y prime belongs to that relation f. If x equals to x prime, then this will imply y equals to y prime also. So this is the standard definition of a function. Domain of f should be the first set A, and for two order pair elements of that relation or the function f, if the first elements are equal of two order pair elements, then their second elements are also be equal. Note that when the option 2 is satisfied by the relation f, we say that f is well defined or single valued. In your lower classes, you may often write a function like y equals to fx equals to something x plus 2 for say. These are also the algebraic expressions, right? In mathematics, we often use the notations x to denote the input. We have to take x as input, which is the independent variable. Okay, f represent the function, which is the rule. Fx to represent the output, which is the dependent variable, right? Why dependent and why independent? Look, for this example, here I choose x as independent variable and fx or y as dependent variable. Why? Look, what will be the values of fx? The values of fx dependent on the values of x, right? Hence fx is said to be dependent variable. Usually we write fx equals to y, and here x is independent variable. Look, if we choose x equals to 1, then what will be fx? Fx will be 3, 1 plus 2 3. If we choose x equals to minus 1, then fx will be 1. So for different values of x, we get different values of f of x. So basically fx depends on the values of x. So the algebraic notation of function is y equals to f of x, as I said before, and for geometrically we write the coordinates x comma f of x to denote a function. Simply if we draw a graph, suppose this is y axis, this is x axis, and this is our y equals to fx. Suppose this is any point P on the curve, say its coordinates are xy, then simply along the x axis we have to go x distance and along y axis we have to go y distance. So we say that this curve is represented by y equals to fx, right? So here there are infinitely many points on the curve. The algebraic notation of function y equals to fx and the geometrical notation of the functions is the set of all the points x comma fx on the curve gives us the function. Remember another thing, a function is also called a mapping, as well as a function is also called graph. Why? For every values of the coordinates of a point we get a function. So functions are also known as mapping as well as graph. Example, look here, fx equals to x square is the algebraic notation of function. Fx equals to 1 upon x is also algebraic notation. Fx equals to sin x, etc. are all the functions. Okay, here the independent variable is x for each case, right? And the dependent variable is f of x or y. Now if we want to draw the graphs of the curve, fx equals to x square gives us this graph, fx equals to 1 upon x gives us this graph, and fx equals to sin x gives us this kind of graph. Now, how to represent a function mathematically? We use the notation f colon a arrow b to denote a function or mapping, and we read it as f maps a to b. Our next section is domain and range of a function. As I have already discussed domain and range for the relation, if you have learned very carefully and watched the video very carefully, then you can easily understand what is domain and what is range. The collection of all the acceptable or allowable inputs is called the domain or preimage set of the function. Here I give the question mark. Why? The collection of all the acceptable or allowable inputs. What is acceptable input? We'll discuss later. The collection of all the achieved outputs is called the range or image set of the function. Let's explain what is acceptable input and what is achieved input. You have to remember some hints or tips to find the domain or range for a function. For domain, we can't divide by 0. We can't take square root of negative numbers for domain. For range, square roots can't be negative, and if fx equals to 1 upon gx, gx is not equals to 0. We'll explain by an example. Okay, look, find the domain and range of the following function. Function is defined here as fx equals to root under x plus 2. So what is domain? All the acceptable inputs is called the domain of the function. We can't divide by 0 and we can't take square root of negative numbers, right? So now look, here the given function is fx equals to root under x plus 2. So basically here we don't have to think about the first criteria or first tip. We have root under x plus 2. So by that second tips of domain, we can't take the square root of negative numbers. So basically for domain, x plus 2 must be greater or equals to 0. This can't be negative by the tips number 2, right? So if we solve this, then we'll get x greater equals to minus 2. So this is the domain of this function. That is, if we write in the set form, then the domain of f is equals to the interval closed at minus 2 and open at infinity, right? If we explain by a real number line, then this will be, suppose this is minus 2, minus 1, 0 and so on, then the domain will be including the point minus 2 up to positive infinity, right? So this is the domain of function f. For range, square root can't be negative. Number 1, if fx equals to 1 upon gx, then gx can't be 0. Here the given function is in the square root form, so square root can't be negative. So for the range, here the function is given as square root form, then this can't be negative, that is this should be greater equals to 0. Here we know that x is greater equals to minus 2. So the range will be the set closed at 0, open at infinity. For x equals to minus 2, this will be 0. So this was the basic concept for domain and range. Now let us explain domain and range in another form. Suppose this is set A, this is set B. The function y equals to fx is defined as f maps A to B. Then all the points, suppose x1, x2, etc. of the set A are under a rule f. For these elements of the set A, we get the images as y1, y2, y3, etc. in the set B. Basically, the first set is said to be the domain of F or pre-image set. Okay, and the second set is said to be the range or image set of F. Suppose you have a function fx as in the order pair form, say x1, y1, x2, y2, etc. Finite number of elements up to xn, yn, say. Then the domain of F is equals to the set of all the first elements in the order pair x1, x2 up to xn, and the range of F will be the set of all the second elements of the order pair y1, y2 up to yn. This is the basic definition of domain and range. You may think about one condition. Suppose there are some points x1, x2, x3, and there are y1, y2, y3 also. Suppose x1 and x2 both are related to y1. This is possible for a function, right? And x3 goes to y3. The domain is the set A. Okay. Now what about the element y2? Here y2 is not related to any element of the domain set. Then the set B is said to be the codomain. Okay, because here the range set does not contain all the elements of the set B. Here range is y1 and y3 because the elements of the domain set are related to y1 and y3 only. Here y2 is left. So in this case the set B is said to be the codomain set. So here range is a subset of codomain. Clear? But for this case domain is x1, x2 up to xn and range is y1, y2 up to yn. Here range and codomain are same. Now simply we can say that suppose this is the set A which is our domain, this is the set B which is our codomain. Okay, and this set which are related to the elements of the domain set is known as the range set. So by the above discussions we can easily find out the domain of this set. Domain of F, here all the first elements of the order pair elements are the domain. So domain of F is equals to the set 2, 5, 8, 11, 14 and 17, and the range of F here 1 only. By using this concept and with the help of these tips or hints, you try to solve this problem, that is find the domain and range of the function f of x equals to root under 9 minus x square. So this was the basic concept of real functions. If there is any kind of doubts or query related to today's lecture, please do comment. In the next video we will discuss about some important functions, their domain, their range and their graphs. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.